Ba-ba-bum. Hey Arnaud, how's it going? Okay, so today's work is going to be um, as oh, I didn't put it in the title, but I've written that in Discord. So the point is, yesterday I was doing some work for implementing a new UDP protocol for D2, and actually we could not test it over the network because it was giving trouble to Neurosite. He figured out like right after I closed the stream what was wrong. So we tested this afterwards, and it works. Test, 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 test. Um, oh, I don't have echo enabled. And it works. Test, 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 test. So it works, but there is stuff that we need to do. So yeah. Um, More precisely, we have to refactor all the temporary shit that I did yesterday just to make it work. We need to make it nice. We need to reimplement cleanup routines so that what is D2? It's a chat application that I'm working on. Instant messaging, voice call. What you saw me open right now, it's the prototype, and it can do like voice calls, screen share. Well, right now it can do voice calls. It will be able to do screen sharing and that kind of stuff. So yeah, let's let's make this stuff better. Decentralized, well, self-hosted. Yes, you self-host a server, and then a client can connect to multiple servers. Yeah, I don't know how old are you, Lemnin, but if you've ever tried like TeamSpeak or Ventrilo, that's kind of the idea behind this. Not in terms of like features or like look and feel, in terms of the fact that uh, when people before Discord, people used to use TeamSpeak a lot, and somebody in your circle would host a TeamSpeak server, or I guess you could pay to have somebody manage that for you. So you just, I don't know, you wouldn't even have to pay much, like $5 a month, something like this, and you would get like a Discord TeamSpeak server. That's kind of the idea. Am I going to publish it? Yes. Right now it's very broken, so I want to reach like a critical amount of features before I publish it. So it's private, but yeah, it's totally going to be public and open source. X2, hello. I guess that's fine. I think we should give read room to room. I guess. Although there's going to be one of these things for room per room. No, never mind. Okay. Although we do need some kind of thing to hold state and stuff. Which name do we give to this thing? Sorry to ask, probably the 100th person to ask, why not use WebRTC? Two answers. One is WebRTC is a network protocol, or rather, two answers. WebRTC is two things, and I have a reason why I don't want to use WebRTC for both cases. So WebRTC first is a protocol, and as a protocol is overcomplicated for what I'm doing now. Meaning WebRTC has logic for doing peer-to-peer. I don't want to do peer-to-peer. Has logic for doing like codec negotiation. I don't want to negotiate codecs. For now, I have like one codec that we use for everything. As the project grows, maybe we will need to implement some of this stuff. And at that point, we will maybe revisit that choice. But for now, it's basically a lot of ceremony, like a lot of paperwork, basically, that you have to do for no reason. And in a sense, if you buy into the paperwork right away, it's kind of harder to then keep control over, like keep an eye on exactly what are your needs. Because then you need to start expressing your own needs in terms of what the protocol allows you to do. And it's not the end of the world, but it the more you do that, the easier it is for you to end up implementing something that is suboptimal really for no reason. So right now I'm basically making a protocol that does exactly what I need it to do at the time, and I grow it organically based on what I decide to implement next. The second answer is that WebRTC is also a library. So if you get libWebRTC, then you have a library that speaks WebRTC for you, and it gives you, high-level APIs where you start a new WebRTC connection session. I don't know what these things are called, but it does a bunch of heavy lifting for you. The problem is that libWebRTC is a library made by Google that has more than 1 million lines of C++ code. 1 million lines of C++ code that you would be pulling into your project. And so as a dependency, it sucks. Because it's C++, because it's written by Google, because it's a ton of stuff. And basically that becomes a key piece of your stack that you have no control over. So that's also bad. Also, libWebRTC has stuff like code for starting screen sharing. Is this a native app? Yes, it's not a web app. So there's stuff in libWebRTC that probably you can avoid using if you don't want to. But at this point, it's much better to do things from scratch, so that I can also learn how to do them, like what the needs are, what the constraints are, so that I can then eventually, if I use a dependency, I can appreciate what the dependency gives me, and I can evaluate it better. What cross-platform layer are you using? For the GUI, I'm using an immediate mode UI, so I'm not using for now any native GUI component. Basically, I just have a 2D rendering context and there's a library that draws lines in there, and so that's how the UI and comes into existence. Eventually, it would make sense probably to add proper native platform native UIs, like have a native UI on macOS so that it feels like a native macOS app, that kind of stuff. But not now, not that important for now. You do Xwell and stuff yourself? Well, I mean, I'm using DVUI. So take a look at DVUI. Search DVUI Zig, and you will find an immediate mode UI library. So the library does that for me. I guess, sorry, maybe the answer to your question would be the DVUI uses SDL. So SDL is the cross-platform way that we use to obtain a rendering context, like a window and a rendering context. Oh, but this shouldn't be like this, right? It should be like this. Okay, I think this is like reasonable. It's not the prettiest, but works well enough, I guess. What, man? What is your problem? Oh, okay. We good now? Okay, we should be good. So, server was mostly fine. We should have multiple rooms. For now, we assume to only have one room. Media server keeps calling read rooms. To read messages from the UDP socket. On certain conditions, creates a new client, puts it in the map. There's a link list. I think I want to get rid of the link list. Maybe we should also do client cleanup. So we need to look at what happens when a client disconnects, and I think I think we can make this all better. So I would say that the room clients is not a linked list. How do we do that? Do we keep pointers in there, but we make it an array list? Yeah, let's go do that. Okay, we make it an array list unmanaged. Then whenever we want to add to it, we stop making this thing a linked list, so it doesn't have next and prep anymore. Don't set next. Don't do this. Instead, we do room clients append GPA client catch unreachable for now. Then this becomes something much easier. There we go. Then what else? When we create a room, that should be fine. Okay, what's the problem? Expected type found. Oh. To be honest, this doesn't seem super important, but like, do any of these things need to be stable? Also, closing is not maybe even that interesting. No, it should be interesting though. Yeah. I think that right now we don't know how to clean up a client because we will get an error. How do we get an error that causes us to close a client? Writing to it fails. Somebody tells us that a client, actually writing to it failing, I don't even know if that's a possibility. Like we oh man, writes in this case, writes they always succeed because it's UDP. So like nothing tells us if the thing is dying or not. It's more like a janitor thing. Hmm. Okay, here's what I'm thinking. I'm thinking that this should not be its own file anymore. I'm thinking that this guy needs to be part of the main server code. Which is annoying because the main server code already has a bunch of stuff in it. Oh my god, more than a bunch. Jesus Christ. But it's not completely a thing, like a fully separate thing. I think that basically the problem here is that we need to understand that rooms exist as a state. They basically exist here, I think. Yeah, and we need to also understand that some of those clients in that sense are UDP clients versus TCP clients. So to implement proper cleanup, we also need to do this. Yeah. Yeah, I think that that's something that we need to do. But it's fine. Should we work on this now or should we prioritize the client? I think I'm gonna try and do some more server work. Not strictly necessary, but I think it's good. So if instead of having like two different realms, we merge them, then that means that we need to slot the concept. These concepts need to be slotted in here somewhere. So how do we make this work? Broadcast. These broadcasts, Is it common to create a singleton using var foo struct equals in Zig? I don't know. Yeah, that's definitely a singleton. It's not only a singleton, it's a singleton and it is also stored in global memory. So this makes both things, because sometimes you might want to have a singleton button that shouldn't necessarily live in static memory. In my case, or rather, you know what? It doesn't necessarily have to be this way. Although it is true that if your thing is a singleton and it's, central enough to the functioning of your main application, there's usually no reason not to put it in static memory, in global memory. So that's what I'm doing here. I don't know how common it is, but it works and I'm doing it. So there you go. So I think that if we do it like this, yeah, we're basically going to need to change this to something that basically keeps tracks of, active calls. I'm trying to work idiomatic Zig. I see. No, that's a totally fair question. I would say this choice is not particularly interesting when it comes to idiomatic Zig. There are other things that are more that you can get more right or wrong than this one. But ultimately, what idiomatic Zig is Zig that is aware of where the memory is coming from and where the memory is going more than anything else, I would say. So as long as you have these concepts clear in your mind and you have one thing that you want to achieve, here it seems like you're using GPA like malloc. Yes, correct. I am. I have a global allocator that I'm putting out here, and I'm not passing around a bunch of allocators. Yes, that is definitely not idiomatic. If you're writing a library, that would be straight up wrong. In my case, right now, I am not hyper-focusing on getting allocations right in my program. I'm leaking a ton of memory right now. Because I keep refactoring it. Like this code, if you looked at it yesterday, it was using a library for UDP networking that required multi-threading, and now I'm switching to a evented library, libxcv. So basically, what previously were a bunch of threads, now everything is being destroyed. So long story short, since I'm still at this stage of experimentation, I'm not yet committing to a specific way of managing memory. But keep in mind, I'm writing an application. I'm not writing a library. When I'm writing a library or even a component, like a subcomponent of this application that kind of acts like a library, in that case, I will be super aware of allocators and do the right thing. For example, I have this, I have protocol, which contains basically stubs, well, not stubs, but like type definitions for messages that get sent between client and server. And every message has its own serialize and parse function. And you will see that these guys are absolutely allocator aware. So they don't assume a hard-coded GPA, global GPA. They accept an allocator. So basically, I am fucking around at the top level because I don't want to commit yet to any specific way of doing things, but I'm not doing that in self-contained components. Why is the allocator param called GPA? No, G doesn't stand for global. GPA stands for so we have also a GPA in the standard library, and that stands for General Purpose Allocator. If you want to talk about idiomatic Zig, here's a suggestion. Don't call your allocators allocator. That's a bad name. It's overly generic. Yes, the interface is allocator, but you should call them either GPA or arena. The idea being that a GPA is an allocator where, for example, if if an error happens and you are returning and you allocated something, but now you can't return it because an error happened down after that, then you want to defer free. While if something is an arena, in an arena, you normally don't want to free things because an arena doesn't free individual allocations normally. So like an arena is basically meant to be used as a scratch buffer. So for example, you have maybe I don't know, it's a game and you have like a game frame, or it's a web server and you have like a request handler which basically runs once to reply to a client, and then every intermediate allocation was only necessary to produce the final answer. That once it's sent to the client, then none of that matters anymore. So in that case, an arena is great for everything that should have the lifetime of one request response lifecycle, not more than that. And instead of GPA, it kind of implies that things are long-lived, more long-lived than that. And maybe something like some memory also changes ownership at some point. Like you make something, but then at some point that gets owned by another part of your application. So abandon alloc or allocator as a name, embrace GPA and arena. Also, it is not a bad idea to pass one of each to a function when it makes sense to do so. Like it makes total sense in some cases to have a function that accepts both a GPA and an arena at the same time. And depending on what they're doing, they will use a different allocator. And if you call them alloc, then you kind of lose that ability. Let's see. You didn't realize libxcv is single-threaded. Event loop makes sense. Interesting choices. Interesting choice. Given that your app is work with playing audio. Well, libxcv itself is single-threaded, but audio is played by a different thread. So the idea, in my application, is multi-threaded. Not everything is handled by libxcv. So in my case right now, libxcv lives in one thread that handles networking, basically. Then the GUI has its own thread. Audio has its own thread. Yeah, so that's how it works. You generally want to have a dedicated thread with higher priority for audio, for sure. Probably same should be true also for your UI. But then after that, I guess it depends on what you want to do. That all makes sense. Allocators are nice, but I still don't understand why the allocator parameter is called GPA, since GPA might be an arena allocator. Because that's the point is how the point is how the style in which you are using the allocator. Yes, somebody could give me an arena allocator as my GPA. I will try to free stuff in it, and that will be a no-op, and that is fine. It's not the end of the world. But basically what you are communicating is how you plan to use that allocator to the caller. And the caller then can decide if for their use case, giving you an arena anyway is still good enough for them, or if they want to give you a GPA. Here's an example. Here's a different example. If a function accepts an arena allocator, meaning it accepts an allocator but expects to use it as an arena, then you know that you do not want to pass a GPA to that function. Because if you do, that function will probably leak memory all over the place because it expects you to be able to call reset on that allocator. But you can't in this case because it's a GPA. Do you have that application that uses libxcv multi-threaded open source? No, it's not open source yet. It's still a private repo. It's not really magic. Like I basically have libxcv running in one thread, and then I use atomics to communicate with other threads, atomics and mutexes, that kind of stuff. So yeah, that's how it works. Obviously, you don't want to have the libxcv thread to block for long. So generally speaking, you want mutexes that are like not that They're not held for too long from other things. But that's kind of it. Like it's there's nothing magic about it. Like there's nothing new that you would learn from reading this specific code that you wouldn't be able to learn by looking at any other multi-threaded application that makes use of mutexes and atomics. It just so happens that one of those threads also has a libxev running in it. That's it. Okay, so basically this is what I want to fill out, the calls struct. I should sleep? What do you mean? It's 1 p.m. I'm joking. Have a good night. Yeah. Have a good night. So we have client is more than just a UDP address though, right? Oh, no, you know what? Actually, it might be, but in practice, not really. What do we have in here? An ID. They have an ID. Yeah, they have an ID and an address. So let's call them UDP clients. Let's get an ID inside here. Maybe. We'll see. So that's a UDP map. Then this is a room. These things should probably go below the definitions, I guess. Okay, so we have the UDP client map. Then we should probably have active rooms or something somewhere. How do you preserve olives? That is a good question, man. I have no idea. I think I've never had olives around in his house that lived for long enough to even go bad. I think that most preserved olives that you find around here are under a they are inside a salt water solution. So like you can buy jars of olives, black olives, also green, both green and black, and they're like in jars that have salt water in them. They're actually also pretty good. Like that gives flavors to the olives in a nice way. I don't know the details of the preparation, so you might want to look into how that gets done precisely. How much salt to put in there, or if anything else should also be put in there. But yeah, that works. Some of those also have chili in them, so that the olives get a little bit spicy. That is the main way I know of preserving olives. But then again, really, I've never had olives around me for long enough for them to go bad. No joke. Okay, we were looking at this stuff, so should we move client as well? I think this concept of messages and clients can be left here, maybe. Well, let's see. Nickname dev. Hello. So UDP client map. And do we want a room map or do we want a room array? I think we want a room array. The problem is maybe we want a room hash map because. Okay, what is this ID? This ID is a U32. There's also a lock here that we don't need anymore. Um, so here we do have a linked list of clients. Interesting. These are all the clients, like these are the TCP clients, basically. Hmm. So what I'm thinking is I need to I need to connect also these UDP clients with their corresponding TCP client. Like they basically are the same thing. So what I'm thinking is maybe that a client, which is a concept that we have in here. Yeah, look, it has connected at, janitor, blah, 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 status, authenticated closing, done TCP close, done reading, pending writes. Oh man, yeah, it had all these things. What I'm thinking is that we need to do the same for UDP, basically, meaning a client can have multiple UDP addresses. Hmm. and some kind of UDP ID. And then here, a client has create, it has destroy, it has request received. Oh, we have received a request from this client, right? And these are channel create, blah, blah, call join request. Oh, these are the various basically commands that a client can make. Although I'm not sure if these things should be functions in the client anymore. And I'm starting to think that maybe they should be things like functions on in the state, like the state can do things for a client, and so these would get moved somewhere else. So we could give this guy also some UDP stuff, something like add UDP connection, that kind of stuff. Ultimately, the reason why I didn't do this also originally was because I assumed that UDP connections could be disconnected from the TCP connection completely. But now I'm thinking that it's probably more practical not to do that and to keep things together. Alternatively, we don't glue things together, we keep them separate, but then there has to be a bunch of back and forth. Hmm. Hmm. Yeah, I'm not sure about that. I am not sure about that. Should those things be considered separate enough? You know what? I think I'm gonna undo some changes here. I'm gonna remove some of this stuff back to the original file. That's fine. Okay, this is where I want to be basically. Let's see if this builds. It does. Okay. Yeah, so basically, I guess I can add like some kind of function here to ask for cleanup. I can add that function to the media server. I can say, yeah, media server, please delete these things. Also, this guy can be in the media server. Yeah, and so IP media server can have like a function that says disconnect all the um, all the UDP clients that have that share the same TCP connection, for example. Although wait, it could it be more than one? It's actually wait. It's actually a one-to-one mapping because the same user can have multiple connections, both TCP and UDP. But actually, one client can have only one TCP connection and only one UDP connection. Well, and up to one TCP connection, and then either 0 UDP connections if not connected to any multimedia thing, or then only one at most. Yeah. Okay. That I think is interesting. So a client here in our case is as an ID, it belongs to a user. That is knowledge that we don't have right now. I guess we can give it a corresponding TCP connection. That would allow us to issue TCP connect messages also from here, issue writes. That does not seem a bad idea. Yeah. Okay, let's take a look at how these connections get cleaned up. Like TCP connections get cleaned up. There's a complex process. Let's see. When it's time to clean up a connection, these flags are set by reader and writer coroutines and checked periodically by the janitor. Once a closing client is done reading and writing, the next janitor invocation will free everything. Right. These are a bunch of flags, right? It's like, are we authenticated or not? Are we closing or not? And if we are closing, then there's a completion about it. Okay. Then are we done TCP closing? Are we done, I guess, TCP reading? And do we have pending writes? Ooh, okay. So what we could do technically is piggyback those pending writes. So whenever we have a pending write on the UDP side, we also increment and decrement this. We don't care about being non-reading for the UDP case, but we do care about the pending writes. That's actually mainly that's the main problem. So yeah, we could observe is if we are closing the connection. Who sets closing? Calling close on a client. Okay. So basically, an error happens anywhere, or technically at some point, this you kick somebody from the server. Among the things that the kick should do is also uh, force close all connections. So that calls close, and so that allows us to observe the closing thing. Okay, that sets and that also issues a closing on the TCP. That's why we need an XCV completion. Okay, perfect. So we could basically tie the TCP connection to the UDP connection, and then yeah, and then do that. Okay. So maybe we should do this pairing. Okay, let's see. Let's look at the state. State has a bunch of clients, and I think for calls we need I guess a map, a nonce map. Is there no map anywhere where clients are mapped by ID? Not at all. So there's a connected at. And if the client is authenticated, we have a user ID in here. So I guess the idea is so I guess I'm using right now connected at as a form of ID for this client. Which I guess works, but it's not the greatest. But it does work. You know what? I'll continue doing that. Any advice on career change from high-level language like Python to low-level like Zig? All the things I see are OS coding stuff, which requires a lot of knowledge. Can you define a little bit better all the things that you see? What are you referring to? Are you referring to job postings in your area? Or in your like time zone or something? Jobs for low-level language. Okay. I don't know what you mean by OS coding stuff, though. I would not expect, like, there's not a ton of people making OSs, and I don't think they're hiring a ton of people. I may be wrong. Maybe that's exactly what you're seeing in your case, but like as a general thing, no, I don't think that would be. I would be surprised if that is really the prevailing thing. So maybe if you look a little bit deeper, they're not just OS coding, but they are something more specific. By the way, if you have a link, I would be curious to see a link. Again, I might be wrong. I'm just going off my impression. But here's another thing that you might find: embedded devices. So there's a lot of companies that do hardware, and they need software for their hardware. These industries are slow moving, and they probably are not yet really embraced Zig, for example. Actually, I can tell you for sure, the hardware industry has not yet embraced Zig, but they probably will at some point. There is so much convenience in Zig. Holy shit. They just need to be made aware of that, and it will happen over time. So that's another one. There's some crypto work in Zig, if you're into that. Solana, for example, is doing Zig. When they do research on what to code with Zig, it's OS compiler embedded, which more requires more external knowledge than average software. Yes, I wouldn't call it external, to be honest, because I mean, knowing how to program means that you should know how the machine that you're programming works to some degree. Maybe that should not necessarily be the first thing that you learn, but eventually you better learn. Like if you want to be a good driver, you need to understand how your car works, right? Maybe not in every single detail, but you need to know more than just what is a steering wheel and what is the abstract concept of changing gear. You need to know more about the mechanics. You need to know, friction, how much you can steer given weather conditions and your speed and that kind of stuff. So software at first sight might seem more abstract than that, but then if you want to get serious, you need to know the machine. Like in this case, I'm writing a real-time voice chat application. Let me show you this. So I'm writing a voice chat application, and I want to ferry audio data over the internet as fast as possible so that they can reach people in a timely fashion. Otherwise, it becomes laggy. And so in my case, here's one important insight. You don't want to use UDP. Sorry, you don't want to use TCP. You want to use UDP because TCP is a reliable transport, but to achieve reliability, it has arbitrary delay that can happen on a TCP connection. Because if a packet is not received, then the connection tries to resend it a bunch of times. So the problem though is that if you're doing real-time chat, you don't have a lot of time to resend stuff because you basically have started playing audio. You have started playing the voice of the other person, and so like you have a cutoff point where either by that point you have the data and then you can play it and that's fine, or if you don't, then it's better for you to skip over that data and continue playing everything else that maybe arrived in the meantime. So long story short, you want UDP, not TCP, because packet loss is preferable to arbitrary delays. So you want to do this. Then if you do UDP, a UDP packet can be up to 64K, 64,000 bytes. Why is it 64K? Because a UDP header uses a U16 to define its size. So that's the maximum number that you can express with that. And the problem, though, is that if you create a 64K UDP packet, guess what happens? The UDP packet gets fragmented on the network at the IP level. And so if that happens, then basically the chances of your packet getting lost increase exponentially because the network, when the network drops a packet, it usually does not drop a full TCP packet or a full UDP packet. What it drops is an IP data frame, that datagram. So the IP datagram gets dropped. And so if you have a UDP packet that's 64K and made up of a bunch of UDP datagrams, a bunch of IP datagrams, losing even one means that your UDP packet is lost. And you don't want that. So that means that when you're designing an audio application, you also want to try and keep your UDP packets small enough that they fit a single IP data frame. And that is not something that you can usually know with full certainty, but 1,500 bytes is the generally accepted, I guess the standard-ish MTU, maximum transaction unit, like the maximum size of an IP packet. So you take 1,500, you subtract the IP header plus UDP header bytes, and that basically tells you how much free space you have, which is 1,472. Then those 1,472 bytes, you decide what to do with them. And in my case, in my protocol, I have like the concept of a client ID, a sequence number, a timestamp, and then the data. So when I'm designing my application, I am aware of these concepts and these mechanics, and that brings good properties to my application. So I guess my point is, nobody is born with this knowledge. You are totally right that is not something that you will learn in university. Well, I guess maybe this kind of stuff, technically you could. There is a course that teaches you some of this stuff, usually. You will not be able to learn all this stuff in university, or maybe you didn't go through university. You did a boot camp or whatever, you learn how to program on your own. So yeah, you're not born with this knowledge. But at the same time, none of this is a endless pit of stuff that is impossible to know. The only thing that can make it impossible to know is if the ecosystem that you're working in is hostile to experimentation and feedback loops. For example, if you are using C, C is a bit hostile to learning, or like even C++. C++, I would say, is even more hostile to learning because everything sucks. Nothing makes sense. Everything is uber abstracted. And so getting fully known knowledge, fully precise knowledge is very hard to get. And actually, you know what? I would say that higher level programming languages are even worse at that. Like probably part of your impression that this stuff is hard to learn is because in higher level programming languages, everything is impossibly hard to learn, right? You want to know how your runtime works? Yeah, good fucking luck. Because every single thing that you do in Python has 10,000 hidden implications that only the gurus can know, right? But that's not how it is in lower level programming. Like in lower level programming, it's more raw, it's more annoying. It's fucking annoying having to do byte counting in a UDP datagram. But man, this is it. That once you do it right, you've done it right. If you try to do something of this stuff in higher level programming languages, you're always dealing with uncertainty. Like for example, people that try to do I remember reading a blog post of people trying to make a Go application more efficient by trying to make the Go application stack allocate certain data because that's more efficient than heap allocating. But the problem is that the memory allocation in Go is managed by the Go runtime. And so they needed basically to massage how they express things so that it would be more efficient for Go. Or like Python also has some of this, right? Maybe you express something in one way and then a slight tweak will make the thing much more efficient. And it's not immediately obvious why that change is important because it has an influence, like it basically depends on a bunch of hidden details. That is never the case in lower level programming. In lower level programming, you want stuff on the stack, you put it on the stack. You want stuff on the heap, you put it on the heap. Like it's always much more explicit and manageable. So I would say don't be afraid of having to gain that knowledge. Because if you use a lower level programming language, you will find that the process is much more straightforward than trying to learn even basic shit in a higher level programming language. That's my suggestion. Okay, we were looking at which editor are you using? Helix. Okay, we were looking at the cleanup procedure for my thingies. So I guess my goal now is to connect a UDP connection to a TCP connection and then use pending writes to also count for pending writes to the UDP address. Thanks for the advice. So what project do you think newbie to low level should do? I've done all of Zigling's. That's a good question. Honestly, okay, here's an like a negative suggestion, like something that I would recommend you don't do unless you cannot think of anything better. My suggestion would be to not do, and then I'll try to give you a good one, I guess. Like a positive one. So a suggestion on something that you maybe should consider trying. Although it's tough. I don't have a good example on hand. So things that you should not do. In my opinion, you should avoid doing Advent of Code in Zig. Advent of Code is a great initiative. It's awesome. But Advent of Code is not a software engineering thing. Advent of Code is more akin to data analysis. As you're solving an Advent of Code challenge, your goal is, so for people who have never seen Advent of Code, that's something that comes out in December. It's basically an Advent calendar, except that every day you get a new puzzle to solve. And the puzzle usually requires, well, always requires you to do some programming. You have to program a solution. So they give you, they explain you the situation. They give you some input as text. Then you have to parse that input and manipulate it, manipulate it until you reach a solution. Advent of Code is really well designed and always on point. But with Advent of Code, your goal is to take a input, like one instance of input, pretty much, your personal one. Every account gets a slightly different variant of the input so that you cannot copy somebody else's answers. And your goal is to take that input, manipulate it once, obtain the answer, paste the answer in the Advent of Code website, and obtain the success screen. After that, you will never have to code your code ever again. You never have to deal with malformed input. They always give you perfectly well-formed input. You never have to deal with well, technically, in theory, your solution should be able to deal with more than one instance of their inputs. But in practice, you don't even have to do that. So like technically, you could even leverage characteristics that are unique to your input. Doesn't happen. It's not something applicable every time, but sometimes it might be. My point is, you're not doing software engineering. Software engineering means worrying about a bad input, communicating, failing gracefully, and communicating that properly. Managing memory, making sure that your application doesn't, leak resources if it's long-lived. In this case, it's always one script where, like, when you solve Advent of Code, it's also a waste of time to do any memory management. It doesn't matter. Like, you just allocate stuff, and then you let the process run to completion, and then US will clean up everything at the end. So Advent of Code is not a good way of trying out Zig, in my opinion, because Zig shines when you're doing software engineering. It is amazing when you're doing error handling, resource management, working with OS APIs. Guess what? With Advent of Code, you really don't even use OS APIs except for reading a file, printing to standard output. That's it. Everything else is an algorithm that you have to implement yourself. So interoperating with C libraries is another thing that Zig is great at. So long story short, Advent of Code is not particularly valuable if your goal is to get software engineering practice. It can be fun, so if you want to have fun with it, go have fun with it. If you want to use Zig with it, go use Zig. It's totally doable. I've done that in the past. It's not that big of a deal. It will be slightly more verbose than using, say, Python, but it works. And sometimes by using Zig, you are able to brute force solutions that if you were using Python, for example, you wouldn't be able to brute force. Sometimes Advent of Code gives you challenges where the simple version can be brute forced, and then they add a twist where now you're basically forced to upgrade your algorithm to a smarter version of the algorithm because a more naive version would have like a combinatorial explosion and wouldn't work. Where exactly is the threshold where, up to which level you can push your naive solution and up to which point, and well, from which point onwards that's not good enough and you need to upgrade? That line moves slightly depending on the programming language that you're using, and the line definitely is way more up than in Zig than it is in Python. In Zig, you can go much further with a naive solution than you can in Python. That said, these are all tiny quirks that are funny that I noticed by doing Advent of Code. But in general, it's not a great exercise for practicing system software engineering. So that's my negative suggestion. Do not do Advent of Code thinking that it's a particularly good exercise for Zig. It is not. It can be fun on its own. You can do it in Zig. You can do it in another language. It's all well and good, but it's not great to learn software engineering. Now, what is a good thing that makes you learn software engineering? Writing a library with a real world use case in mind. So a database client can be fun. It's parsing and networking and understanding how to write a library. That's one. Another one could be implementing some data structure, although I would say chances are that you're not going to do a particularly good job at that, and you're just going to implement a um, um, shitty might be a too strong of a word, but a not particularly fine-tuned data structure that nobody will want to use because it's not tied to a specific use case. It's going to be overly generic, and chances are it's going to do a bunch of heap allocation or be inefficient in ways that that are not important. So you know what? Avoid the data structure. But client library, database client library. A TUI application, that is definitely a good one. What else? Yeah, you know what? The truth is, I think that the best way of doing this would be to scratch your own itch. Like, see something that you would like to make because you think you can do better than existing solutions in terms of design, maybe, and then maybe you don't know fully how to do the implementation, but then you can learn that along the way. I don't know. Like in my case, I've made this TUI Twitch chat client for myself because I wanted to have one. I'm making a Discord alternative right now. I wrote a static site generator with a bunch of related stuff like a language server and a bunch of parsers and sub languages used by it. So I don't know. In my case, I was able to always scratch my itch. Basically, like Bork was a itch that I wanted to scratch because I do live coding. Zine is another itch that I wanted to scratch because I do a bunch of static websites, and Hugo was driving me insane. D2, guess what? It's because legacy Discord is en route to become enshittified. So I want to basically be able to bail out when that happens, which is not going to happen tomorrow. But at the same time, I'm not going to be I'm not going to be done with D2 tomorrow. So hopefully I'll make it. I'll be on time. We'll see. Some people like to make games. Will D2 be self-hostable? Yes, 100%. That is part of the goal. Not only self-hostable, it is designed to be self-hostable, and it is designed to be single executable self-hostable. No Discord, no Docker, no weird bullshit. The database is SQLite, so it really is meant to be easy to self-host. I'm really thinking that we should unify these things. Oh, TCP and UDP. You know what? It's fine. I'm not gonna do this now. At this point, let's go fix the client. I'll decide how to commit for the server afterwards. Let's fix the client. The client is a complete mess, so we definitely want to do better here. So first of all, we're calling this thing SRT thread. We don't have any SRT anymore in this code base, so let's see. Let's not call it SRT thread. Let's call it media.run. Also, this shouldn't be a thread anymore, like a separate thread anymore. This should be something like that runs in a thread. And I'm also thinking that this should be like I guess some extra duty that's taken on by the main network layer. Underscore underscore state and underscore 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 state. Well, that's the client. Where do you see? Did the server have underscores in state? No, it did not. No, everything is triple underscore. The triple underscore state for the client is just because of it's because it's a singleton, and I want to basically gate it by locks with locks. So basically, you use lock state to obtain a handle to the state. And the triple underscore is just to say, yeah, you're not supposed to access this variable directly because you always should be grabbing it while locking it. And so you basically use lock state. That's it. And that gives you something that contains a pointer to the state and a unlock function to unlock the mutex. That is the idea. Not as funky as it might seem. So yeah, I was saying, you were saying our intent is to connect. So we have an intent to connect, and then we decide to actually commit to connecting, and this would spawn a thread. But now what I would do instead is kind of issue a command to the network thread and have the network thread set some of that stuff. Although, let me think, because in reality, the network thread should do some of this, but also we are setting some state in the audio stuff. We are opening audio streams. Will Zig make it not a language feature? Private fields? No. Private fields are not going to be a thing. In my case, that's not even a field. That's a global variable, but which I could make more private. The problem is that even code in here, like even code in this same file, should lock the state and not access that variable directly. So there's no language feature for that. Like if this were, I don't know, like if this were C++, I would have a similar problem. Like I would have to define that variable somewhere, and so this same file would be able to access it no matter what. I guess. Wait, I guess if that thing was wrapped in a struct, and if it was a private field or something, I don't know. But like, long story short, I don't think it's particularly relevant here. I'm doing something funky because that thing is a singleton. So since it's a singleton, it doesn't have, the usual lifetime scoping rules of a variable where it's defined like in a function frame somewhere, maybe heap allocated, but then receiving a pointer to it is not. It can happen only through quote unquote pre-approved channels, but in this case, it has to live somewhere. I guess what I could do is move it to another file, keep it private there, and only make lock state public. So in that case, you know that you wouldn't be able to access it directly. But I also think that sometimes there are some conditions where I know for a fact that locking is not necessary, and so I bypass that. I think the loading thing we saw doing it, yeah. For example, for loading, we know that we don't need to lock it. So I would say what I'm doing is weird enough that whatever the language should do shouldn't have any, like what I'm doing here shouldn't have any bearing to what the language decides to do. Or should not do. Okay, so now I have to decide, how do we do this media thing? Because we definitely want to kick off a like a UDP thing, but also there are some things that we want to keep around, initialize up until we decide to basically close the connection. So maybe I could just spawn a thread to hold this data. That seems like a waste. How would we do this? So Mediator running it basically has a bunch of initialize this, initialize that, and then defer freeing it, expecting that you only return from that thing once the call is done, which is actually neat. Which is actually really neat in so many ways, because it allows you to put the resource initialization in its cleanup, one next to the other. And that is something that I don't want to lose, because if I move it anywhere else, I will lose that property. I will have to decouple initialization and cleanup, which is going to be maybe a little bit junky, but at the same time, it is true that whatever you put in there is also like a singleton. Like, oh, there's a, I don't know, microphone stream. Well, guess what? There's only going to be one. So in theory, we could put here the initialization code and somewhere else the de-initialization, wherever we decide to de-initialize stuff. Huh. You know what? Let's call it run thread. Let's keep it a thread for now. So that we can have this property. Initialization, de-initialization, stream open, capture buffer, blah, blah, blah. Right. Receiver. Oh, fuck. Right. Now I remember what the problem is with this. Right. Right. The problem is that if by doing this, we end up having to use a second XCV loop that we don't want to use. We want to connect back to the network one, which we could still do, actually. Basically, all we need to do is like, we need to get a handle on the loop. We need to get a handle on the loop. So const loop equals network dot what? Give me the loop. Where's the loop? Guess what? Despite being a singleton, basically the loop is hidden in here. So I guess we could put it here. Is this a non-runtime thing at all? Oh yeah, it's 100% not a runtime thing at all. Loop handle is undefined. Yeah, I meant that I could not call loop init at comp time. That has to happen in a function because it has to happen at runtime. So technically I can do loop handle now. Where's the auto completion? I have it disabled. I don't really love how the auto completion works in Helix. Unable to load source client network.zig app/network. So this gives us the loop handle. But we are already doing a bunch of bad work. We're doing a bunch of work in the wrong thread. Okay, I think I get it. Basically, what we want to do is have this thread do the audio initialization stuff. Run thread does all the audio initialization and sets up all this stuff and then waits. Like it gets basically up to here and then it waits for the it waits basically for the call to be done. This is wrong. This is not gonna be nice, but I'm gonna leave it as that for now. I'm gonna fix it later once I move the other stuff. So while call.status.get yeah, something like this. Sleep for a while while we wait. Is that Helix or Neobeam? Helix. It's Helix. That's the idea. And then all the networking stuff we make happen in the network thread. So I guess we set up the audio. The problem is, though, that we need handles to these things. Now that I think about it, the network will need handles to some of this stuff. Understandably, honestly. So SRT was kicked out. Yes, what happened? Is there a recorded stream I could watch when that happened? Good question. I don't know. Yesterday I did some work, but I can give you the TLDR. So SRT has the problem that, as I explored it more, seems to me to be a library not exactly for real-time communication, but more like for near real-time. Meaning, imagine that you're like doing, I don't know, like a TV show kind of stuff where you need to move around video audio streams. And you don't have the necessity for them to be exactly real time, like a voice call in Discord, but they should be obviously near real time. But you are willing to sacrifice some delay for better reliability, so that you have a chance, for example, to resend them a packet that was dropped, for example, that kind of stuff. So because of that, the primitives that it gave me were designed to support that use case. It did not, for example, it supported the idea of having redundant connections, meaning you have two hosts that are connected through two different connections. Imagine like maybe one is, provider A, provider B, one is over cellular network, the other one is line connection, like telephone connection kind of thing. Fiber optic or whatever. And so it has the concept of using one as a backup for the other. So you basically open two connections. Both connections exist at the same time, but only one at a time gets used. And when one is degrading, the other one kicks in. Or you can use them at the same time, and then the other side basically deduplicates. In a sense, it ensures that if you send everything through two connections, and so if a packet is lost, the thing ideally would be lost only on one connection, not the other, and so the other side gets better reliability, that kind of stuff. So these are all features that we don't need in D2, and making those features work with our use case at some point seemed not really possible anymore. So I decided to just roll out my own UDP protocol, and I tested it, and it turns out that internet is working well enough, at least for between me and like the United States, that even if you have a giga naive implementation where you don't even account for out of order packets or anything, it still works pretty well. Like I was able to have a voice call and hear other people perfectly. So long story short, I basically decided to commit to this route and to kick out SRT, because also SRT was a C++ dependency, which meant that, that's a chunk of code that I have no control over. And in conclusion, also SRT, you could either use it in blocking mode, or if you used it in async mode, I don't know which APIs it would use under the hood, and I want to be able to use IO ORing for all this stuff for efficiency for the server mainly. Like I think like the server should use the most efficient networking APIs at its disposal. And now that I'm using libxv also for the UDP stream, I'm also getting that. SRT didn't seem to have anything of the sort. The only non-blocking interface that it was offering was EPOL-like. Also, SRT had this concept of establishing UDP connections, which is fine in a sense. Like it's not a bad abstraction, I think. Did you get TLS working on libxv? No, I haven't even attempted. Right now, TLS is not on my top list of things to support. Also, it would have to be TLS on the TCP connection, sure. On the UDP connection, I'm not sure. I think that the UDP connection needs to work in a different way. Probably like encryption negotiation should happen in the TCP connection, and then that gets kind of preset for the UDP connection, that kind of stuff. We'll see. Okay, I hope this answered the question. It seems like Zig has thread local variables. Yeah, it does. But how is it handled in the language? There's a thread local keyword. From what I understand, I need to know about how thread are spawned to set them. Does it mean language knows about stdlib? No. No. If I have to be honest, I don't fully know how thread local variables work. But they are a runtimey thing between... I think it's... I think a thread local variable is a OS feature. The linker has to do something with it. You have, I believe, to request to enable thread local support. And my guess is that the way it works is that whenever you fork, you have one special page, or well, one special range of pages of memory that basically doesn't get shared, that gets always duplicated between different threads. You know, kind of like when you have different processes, when you fork another process, then the original memory is the same, but then it's two copies, they diverge. While if you fork a thread, while if you spawn a thread, memory is shared between different threads. And I think that thread locals are basically multiprocessing memory behavior, but for threads localized to only thread local variables. So you mark a variable as thread local, that puts that variable in one of those special pages that don't get shared. And so when you spawn a new thread, the other thread gets its own copy. I'm guessing, by the way. I honestly don't know. I've never looked into it deeply. But if it's not how I described it, it's probably something fairly close to what I did say, I suspect. What library are you using to get audio? I'm using Port Audio, but I'm not super happy with it. Personally, I've never used a thread local in my life, pretty much. I never felt the need. I guess I can see that being useful sometimes. But I don't know. I don't know what would be, the quintessential use case where using a thread local is definitely the right choice. Because at the end of the day, if you think about it, it's like it's convenient, but it's not really necessary because, every thread local could totally be a memory allocation place somewhere else that you just map to the thread existence. That said, I don't think the feature is necessarily bad. I don't know. I don't have a strong opinion. Yeah, to be honest, my all my red syntax highlighting is kind of a bad choice also for me. I don't know why this theme is like this. I don't know. Maybe I should switch. Should I switch to something like Cat Puccin or something? Please don't save Groovebox. I don't like Groovebox. No Groovebox for me. And tips for someone migrating from C# to Zig? I don't know, man. Molokai Tokunite. This is Helix. Are you actually giving me a Helix command? No, you're not. Tokunite. Yeah, those are definitely. Oh god. You know what the problem is? I really like this general, like, you know what? I like the theme. I like One Dark. It's just the syntax highlighting for the language. Like, I guess I like. Is that part of what? What is this cappuccino stuff? Frappe, latte macchiato, mocha. Man, every time a light theme flashes in front of me, my eyes die, and I can't even recognize what shows up afterwards. Jesus Christ. Dark Knight Contrast. Holy shit. Oh my god, my eyes still flash from the previous light theme. Jesus Christ. Dark Plus. Default. Dracula. You know what? Maybe what I should do is uh what I should do is leave One Dark. Um leave One Dark and then try to change the color scheme for syntax and highlighting only. Yeah, GitHub Dark is not bad. GitHub Lite, god damn it. Groovebox. No, man, I can't do Groovebox. I'm sorry. I'm sorry for all the Groovebox people, but I just can't. Like the ones that keep identifiers white. That is an interesting idea. I mean, in this case, what is changed is fields, right? It's like identifiers, but that are like parts of structs and that kind of stuff. One darker, one light. Oh no, one light is evil. You know what? Maybe what I would want is one dark, but with a one darker syntax and lighting scheme. Hmm. How do you change these themes in Helix? Like, I would like to see basically one dark, but then you paste in there syntax and lighting coloring for from the one dark here, right? Version. Yeah, it's in the runtime stuff. Actually, I think I can do this. Tag red. Yeah, there's a few things that say red. And I guess we can change red from being some kind of red to something that isn't as red. Like we can change that to something bluish. What if my red was also a blue? You're right. I can't just do this. Okay. Then we change the dimension of red. Like tag blue. Actually, like yellow, I think, for keyword. Maybe. I don't know. Blue. Import blue. Purple, 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 blue, blue. Parameter blue. Or we can leave this white. Is there white anywhere? Ooh, I can remove italic from comments. Oh god, yes, please. I hate italic from this fucking theme. Other member, white. Markup, we don't care. Diagnostic can stay red, I guess. Blah, blah, blah. UI, I think, can stay as it is. Okay, let's see how this goes. Now it's a lot more blue and white. I mean, I'm fine with it. I don't hate it. Probably could be made better, but as a, quick change, I like this. Oh my god, I also love that this is not italic anymore. Like, I fucking hate italic from JetBrains Mono. I use this. I remember we used the syntax theme from the site. The syntax theme from the site is a mess. There used to be one guy in the Z community that was very opinionated about themes, and I believe he was working on some Vim theme that even Andrew was using at some point. I don't know what happened to that guy. I would have actually have loved for somebody who had that kind of interest to basically provide some kind of like official universal Z theme. I know it was you. I know it was you, Hayes. I don't remember. I don't forget. But then that guy went and started programming in Rust and Lisp, so it is what it is. Is there a predictable way of building a Z compiler? I've tried to build normally, but I get building linking problems. The official website, the official repo in the wiki section has a guide on how to build from source. If you follow that guide, you will get reliably. You will succeed reliably, but the guide tells you to build your own LLVM, and a lot of people don't want to build their own LLVM. They end up downloading LLVM from Brew, for example. And guess what happens when you download LLVM from Brew and then you try to build with Zig? You get unreliable results because it depends on how it got packaged. Every single time a new LLVM version comes out, the packaging of LLVM becomes a little bit wackier. So don't do that. Do build LLVM, just like the guide tells you. Do that and you will succeed reliably. Okay, what was I doing? So I was saying we need to create a network command. So network, media stream start, host connection, and then protocol media needs to have a media stream start, which I'll tell you doesn't exist. So let's create a media stream start. Oh, open stream. I did have a open stream message. Interesting. Okay, let's go do that then. Let's uncomment some of this stuff and let's make it real. Although now we need to be more aware of our UDP packet data structure in general. So let's also do that. Let's move this below because we don't know. So OpenStream. What does OpenStream look like? OpenStream doesn't really have a request and response per se because it's UDP. So it's more like you send it once. We could send confirmation from the TCP connection, but that is not really that interesting. We should send maybe just a heartbeat. The problem is that the heartbeat could be lost. So what do we do if the heartbeat gets lost? I guess we assume that the connection is open for like 2 or 3 heartbeats. Maybe sending confirmation to the client through the TCP connection is not a bad idea. Like we tell you, yes, it succeeded. Well, let's start by writing the code to get this this message here reliably happen. Okay, OpenStream. Serialize. In this case, I think that for the UDP stuff, serialize should expect to be given a buffer that we write into. And then we return a slice, I guess, how much we've written into it, basically. And so the way this works is... I guess we would just want to write in there a header. Oh no, don't ask me the theme. The theme, I just modified it manually. It's one dark, but I modified it. So rewind the stream for like, I don't know, 5 minutes, and then you will see me make the changes. Okay. Open stream request. So open stream request is, maybe I should divide them into like TCP and UDP messages. Probably not a bad idea. Hmm. 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 No, it's more than just that actually. Because OpenStream is a header. Should I call it like an extern struct? So it has a header. And then it has a, actually the timestamp itself, honestly, is not something we want. We want the sequence number, I guess. Technically, there's also news that we could use for this stuff, honestly. Oh, man. Actually, a well-designed packet probably wouldn't do any of this stuff. We'll set this to 0. It would set this to, I guess, 1 if we want to keep the same header. Yeah, honestly, it doesn't really need to have any of this stuff. It just needs to be from a address that we don't recognize. Hmm. Yeah, because we have all the IP information actually that gives us a lot of information. So we even need to have a header. Okay, let's copy this and let's imagine that we want this. We want our own version of this. Okay, how would that look like? Actually, wouldn't have that. It would have uh, it would have, I guess, a user ID. Hmm. I guess we do want the timestamp. We want the client ID, that's for sure. Actually, we want the client ID more than the user ID. But the client ID is 64, so we can do it like this. To have the client ID, oh, actually, is it really that big? Just server, I guess. Oh, it is. Although it doesn't have to be this big. Yeah, it really doesn't have to be this big. Okay, it's fine. For now, we leave it at that. Then we have, yeah, a timestamp of when this is happening, and then we have um actually, let's put this stuff above the timestamp, right? And then we have some kind of security secret number thing. I guess we can do we can afford a 64-bit secret number. I guess we can call it nonce, maybe. It's basically a one-time only secret value to ensure that you really are who you think you are, or who you're claiming to be. And the idea is that the server computes this, like chooses just that number at random, and gives it to the client through the TCP connection, and then we get basically that value repeated back to us from the server um, over UDP. Then timestamp. And then that's it, actually. We don't even need any other data. What else do we need? I guess for now we don't need anything else. So that's 20. That is 48. 48 means 15, well, 1452. So I guess this is the OpenStream basically packet. Client ID, secret. Hopefully a 64-bit secret is secret enough, but should be. Am I correct in calling it nonce? I think I am. Arbitrary number that can be used just once in a cryptographic communication. Yeah, that's exactly what I want. Yeah, this is basically our one-time secret password. Okay. Actually, I don't even know why we care about the timestamp. I guess we could care to say if we received the second, like we received two nonce requests from a client. What do we do? Well, I guess we can ignore repeated ones. What if you try to connect and then immediately disconnect and then try to reconnect again to something else? So you would send me a client ID nonce, and then I could accept it, but then in the meantime, you also disconnected already. And then you send me another one. So what should happen technically? I think the TCP connection should have set up all this state for us in a correct manner. So we should basically always see that the nonce doesn't match. So the timestamp is actually useless, I think. That's it. It's like two numbers. There we go. Well, okay, the malicious stuff probably doesn't belong here. That's a bigger topic. Uh, okay, this is interesting. Okay, let's think about it more. I'm doing something. I'm doing something wrong. I'm doing something wrong because we need to actually recognize what this thing is. What are you building? A voice chat application. And I'm implementing the UDP protocol. So I'm doing something dumb because if the connection, so right now the assumption was, oh, I will know what this packet is because the first time you send it, you're not connected. And so I know that this should be this. Yeah, but in reality, yeah, if you send it to me again, for example, I think we are connected, then I won't be able to distinguish it from a normal like stream packet. So it still needs to have the header. Like it needs to have a header that says what this is. Hey, neurosite. So this means that maybe we want to move this packet sequence number even above this guy. And we use the packet sequence number as a thing where we use the 0 value to indicate a connection message. Yeah, because in that case, we really don't care about the client ID. Like client ID isn't even a thing. The only alternative would be we do place something else in there, but we don't even have anything else to place in there. God damn it, because everything is bigger than that. I guess we could have a 32-bit nonce. I guess. You know what? At the end of the day, it doesn't really matter. For now, let's copy this over and just keep it as is. Connect means sending a first UDP packet that sets up that opens ports in routers and stuff and lets us know which UDP port you have opened so that we can use that port to send you data. It's the first packet. Like read this doc comment to see what I mean. I guess. Yeah, so we keep the header always consistent. I guess this unused stuff is what we can use in the future. Maybe. We'll see, I guess. Okay. Now, I guess the question is, well, I guess that's kind of it, basically. Should this return an error? I guess we need some error checking. Like I'm asserting that the message is good, but then that means that if I'm asserting this, then somebody needs to check this beforehand. And yeah, we don't really have a way to do that. So I guess we can make this either return an error or return an optional and fail. You know what? Let's do it an optional. Then we can say if return null. Okay. So let's assume that this is the OpenStream request. So we were creating this for the utility of network. Then let's call it OpenStream. D2 protocol, media connection, details, parse, MCD. Oh, we did receive media connection details. Oh, that is nice. Oh, right. There's also like the voice channel ID. Kind of forgetting about an important detail, huh? Probably we want to also put that in there. Happens to be a U32 also. Interesting. Really doesn't contain anything else? Who calls us? Because we need to know what the server is, I think. Although technically, no. We do not need to know that. Yeah, but we need to know more than the port. Let me think. We do need to manage the resource, though, in a way that is like if you delete the server, we need also to close this UDP connection. That's for sure. So we need to know what the server, which server this stuff corresponds to. So we need to wire this information back and forth. Yeah. So we get this because the network received this from a server. Yeah, but like host sync has the host in it. Like channels update has channels. I'm confused. How do I know what's the freaking server? I guess I always assume that it's the server 0 basically everywhere. Oh no, sorry, the server 1. That's what I've been doing. God damn it. God damn it. Okay. So I guess we got server 1. That's H. Although I don't know if this gives me a host connection. What does it give me? That gives me a full host. Where do I get the host connection? I think we don't have those here. Who has those? Oh, it's host client only connection. Wait, why is this? I'm confused. Host connection, it's this guy. What is this thing then? It's the network connection plus status. Okay. So it's h.client.connection. It's a pointer even. Dot handle. Okay. Let's add the voice channel ID, I guess, in the protocol while we're at it. Actually, this is much less now. 28, 16, 20, 32, 28 plus 32, 60, 40, 14, 40. I mean, we don't need to count. There's going to be more, and it's fine. Whatever. Oh, whatever. Hmm. Oh, now we have two client IDs. Fuck. I guess we can call it TCP client ID. Okay. Perfect. Those are the port. We don't care about port because we hard code it. So the part is totally not interesting to us. Now, the idea is Mm, we're missing the client ID now. We need that though. Yeah, we do. Yeah. Oh, it's telling us also which one. Wait, now that I think about it, we don't want to let the client tell that to us. We want to discover that from our server state. The client already expressed interest in connecting to voice. We don't need to repeat that. That's dumb. No voice. No voice. No voice. No voice. Just client and nonce. Yeah. Clamared. I'm at the beginning-ish stage of my programming career and have been bouncing around doing everything. Python, React, JS, Rust, C, Go, everything. I have finally decided that I just don't want to work in web. It seems like a nightmare, and to be honest, not the stuff I find interesting. I enjoy the lower level stuff, but I don't really like the idea of making firmware or something like that. Kinda lost. What do you think is a good sector to get a job in is? Clamared, my advice would be to not consider the web to be that bad. Not saying necessarily that you need to work in the web. Not saying that you need to chase every web trend. There's a lot of dumb shit happening in the web all the time. There's a lot of dumb ideas that are pushed forward by a ton of VC money being poured into into stupid startups that do stupid shit, and then stupid developer advocates. In turn, the money flows down to developer advocates who give who do a lot of work to convince you that you should develop according to the way that they think you should be developing, which coincidentally happens to be by using the tool that their company sells. So yeah, there's a lot of silly stuff happening in the web. Spoilers, the same happens also in other contexts. It just happens at a lower pace. Slower pace and lower intensity. That said, the web is extremely useful. If you decide to make a project, like a software project that isn't web at all, you will still want to make a website for it. If your project is super good, but you don't have a website for it, and you haven't written, a nice documentation, you haven't made a nice website for it, you will suffer. Like adoption, user interest, interests from the public will suffer because of that. So there are very real advantages in being good at making websites. There's obviously a point where you start hitting diminishing returns. But I guess my point is, do not become one of those people that think of themselves as real software engineers because they don't do web stuff. And then whenever you make something, the best you can do is write about it in a moldy mailing list that only boomers even know how to use. Don't do that. Learn how to make a website that explains the value of what you've been working on, also to normal people. Okay, setting that aside. Okay, fine. You don't want to work in the web. What do you do then? Yeah, that's a good question. I honestly don't have a great answer because I guess it depends on how your job market looks like, where you live, language that you speak, time zone that you're in, that kind of stuff. So, what might be true for the United States might not be true for Europe, and the same with other parts of the world. So what suggestion can I give you in that sense? There are still lots of systems development jobs around. Not everything is web or embedded. Yeah. I would say that if it was me, personally, I would be more interested in the details of what exactly is that the company does, more than the general field that they're in. In a similar fashion, when I was in university, okay, story time. When I was in university, which apparently I've been told recently it was a very long time ago because I am, and I quote, fucking old, apparently. So this was, by the way, I graduated in 2014. So, 10 years ago. Not yesterday, not that long ago. But in any case, back when I was in university, I had a very keen interest in recommender systems. I really loved the subject. I think that even still to this day, it's a subject that I really think about and care about. The problem is when I was choosing, like in university, you had the first year of university would be the same for everybody, and then you could start choosing your own specialization in my university. So when I had the opportunity to start choosing my own destiny, since I liked recommender systems, I kind of wanted to do the courses and like follow the classes that basically made sense to follow if you want to do recommender systems. The problem is, in my case, I discovered at the time that all the shitty professors were in there, and all the good professors in my university, for some reason, they were all basically doing bioinformatics. And I personally didn't have a ton of interest in bioinformatics. Didn't hate it, didn't love it, didn't even know too much about it. Like I knew that in general, bioinformatics, it's like basically like either simulation, like protein folding, that kind of shit, or it's analysis of like genetic material, like DNA, that kind of stuff. But so in the end, what I ended up doing is I didn't choose based on my interests. Instead, I chose based on the best professors that I had available to me. And so I ended up doing bioinformatics, and I do not regret it one bit. In hindsight, that was without a doubt, without the shred of a doubt, the right choice. Following the better professors, because I've seen what the other motherfuckers were doing, and it wasn't pretty. It was ugly as fuck. So similarly, I would say that you might have an interest in specific fields. That's fine. But I think that you will find that the metric for choosing a job versus another should probably be more about other things. For example, well, here's one that is obvious. Compensation, right? Depending on how much they pay you, that should be a big factor. Another one should be what is it that the company does? Like if the company is doing, let's say that you would like to do some lower level stuff that isn't firmware, and there's a company that does that, but guess what? They're a consultancy company, like they're a consultancy firm, and instead there's another company that is doing embedded and web. So the two things that you didn't seem particularly interested in, but they're doing that for their own product, because their product is a device that has, a web interface, and it's a good product. I don't know, like not a shitty, vacuum robot that goes around the room and gets stuck. But it's something more interesting. I can promise you that you will have a dramatically better time at the product company than the consultancy company. Most probably, this is all hypothetical. So, but chances are that the consultancy company, even if they happen on paper to have projects that use technologies that you like more, there are other things that are more important. How much you get paid, how much stress is at the company. Like, is the company well managed or not? Is the projects that they work on good or not? Meaning, the project should be interesting in its own right, but it also should be done well. Consultancy companies, more often than not, are not paid to do things well. They're paid to do things on schedule, and quality ends up being, I don't know, whatever they can do in the given time frame, in the time frame that they are given. So my recommendation would be, more than anything else, avoid consultancy if you can, because I think it's just a meat grinder 99% of the time. Try to find a product company that has a product that you think is nice. And then I think that will make things much better. Then ideally, you should find a company that doesn't have stupid ideas about software development. And that also is hard because well, guess what? What I mentioned earlier, right? There's a bunch of companies out there that are like paying to pump out quote unquote learning materials. They try to teach you that everything should be object-oriented, clean, hexagonal architecture, event-driven, blah, 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 microservices. And right. And then companies eat that shit up. And of course, they need to make a tiny thing used by a handful of people, but you gotta do it using microservices. Otherwise, it's not cool. You want to avoid that if you can. Yeah, and I think that is more important. That said, yeah, more in general, assuming that that is available to you, and then the only question remains, okay, but then what type of job do I do? Let's assume that all companies are equally around you, are equally good in that sense. So not perfect, but they are like all comparably good/bad. And the only thing that changes is what they work on. Then what is a subfield that is worth specializing in to get access to jobs that aren't web or firmware, and that I'm not sure. There are companies that do hardware where their hardware maybe, oh god, it crashed. God them Bork. Let's see. I lost 2 years of my life to a consulting job, absolutely soul draining, never again. Yeah, I'm sorry, Northside. It sucks, yeah. There are companies maybe that have a hardware product, but maybe the hardware product is complicated enough that you don't just write firmware for it, but there's also a software component that is systems, but not firmware. There are some interesting projects out there, but it's a little bit hard to get hired for, but still not impossible. So, for example, let's say that you have a super keen interest in web browsers, and you want to make your own web browser. You might find that if you start contributing to Ladybird, for example, and you do it for long enough, maybe at some point that could become a viable career path. No promises there, obviously. Like I would say that statistically speaking, what it just gave you is bad advice. But you can occasionally find things that you can get into so much, so well, that that can become a low probability, but not impossible career path, at least for part of your career. There are people who have worked on Ladybird back when it was just a hobby project, and now that Ladybird got funding, now they're being paid to work on it. So that's one example. Technically, Zig is similar because it has a foundation and it pays core developers. And there was a time where people were contributing to Zig, but they were getting nothing in exchange. Now things have changed. So yeah, there's also the component of get involved maybe in projects that you really like. So don't do that necessarily, with the goal, oh yeah, I'm gonna contribute to this, and like in a week, in a month, in a year, I'm gonna get paid to do this full time. Usually it doesn't work out that way. But being social in an open source sense of the word can pay off. And if you do it with the right attitude, it can just be an enjoyable activity to do in your free time. And that can be also a nice way to get more knowledgeable of specific subsets of things. So with the idea that eventually, you can, maybe you're not going to be able to do that open source thing full time, but you will be able to get hired to work commercially on a commercial product that operates in the same general space. So for example, let's say that you become knowledgeable on how to write a real-time multimedia stuff. There's companies doing real-time multimedia stuff all the time, and so you could get hired by one of those in the end. Okay. No problem. Well, here I was assuming that I would have a buffer, but I don't apparently. Interesting. Yeah, we probably want eventually to have no field name client ID in struct media header. What? Oh, it's because .id. Yeah, but this is not that simple. OpenStream means setting up the UDP connection stuff. Hmm. Hmm. Connect, read, queue. Oh my god. And then we need to have like UDP. There's a sock. Then we need to write the UDP. So we're probably gonna need a UDP write queue. We're gonna need a bunch of completions. We're gonna need a read completion. We're gonna need a read buffer. You're also going to need some state management. Oh man, there's going to be so much stuff that we need to add to this bad boy. Whew. Yeah, I think that this is not worth for the stream. There is so much janitorial work that we need to wire up for managing a UDP connection that is like connected to our main TCP connection, and we need to make the lifecycle work correctly. I should probably start writing. Also, I think I should also start driving some schematics so that people can get a vague idea of how it's supposed to work. Is it in the UDP spec? It is. Well, not exactly, but it's assuming a 1500 byte IP datagram. Then an IP datagram has a 20 byte header, and then UDP has a 8 byte header. So if you want your UDP packet to fit in one IP datagram that has a maximum that has an MTU of 1500 bytes, then that's 28 header total bytes that you need to subtract from 1500, and that gives you 1472. So yeah, there's gonna be a read buffer. Then we need to do something for writing. It's gonna need a write queue. Oh, it's not also that. It's also read s xev xev dot udp dot state. And one stays undefined. A lot of networks will have an MTU much lower than 1500. Well, those networks suck. That's my take. I don't know. I've seen 1500 being used by a bunch of other libraries. Minimum is 1280. So you're saying that to be maximally conservative, we would want to assume that. So I guess you're saying that basically if somebody has an IPv6 address and we force everything to be 1500, then basically we're going to have some monkey business happening. I don't know. We'll see. Is there no write queue for UDP? There is a write queue. Oh no, there is no write queue, period. But this shit also wants a state. God damn it, man. Okay, so you're saying we should maybe be even more conservative? Mm-hmm. Thank you. Yeah, I'm not gonna change this now, but good to know. Probably it's gonna be worth fiddling with this stuff at some point. Okay. Oh, this is the address code that we have in media, I think. Yeah. I guess we can initialize everything else afterwards. Yeah, so we have a write, and then we need to set up a read. Yeah. Okay. Man, there is so much work. There is so much work that needs to be done to move this stuff around. You know what? I should make myself some more tea. Uh, so this is not just a random header. This now needs to be a something better. This needs to be a proper open request. So I guess we need also a send buffer. No, but we can't just have one. We need to have a bunch. Whoops. I need to copy this message concept needs to be in D2. Maybe we should call it packet. We put it in protocol and we call it packet. And we need to turn these into proper library code. So we could have in protocol a message pool. Let's call it packet pool. Maybe we say that we send packets because this collides with a D2 message. Although a message is a chat message. Do we call it a chat message at all? No, we just call it message. Network message? You know what? We can call it a network message. Network message pool. Maybe we make it generic so that we can decide how big message is. We can create a UDP one where these bad boys are, or they have a heap allocated length. Yeah, no, they have to be different because over TCP, they really don't have a max size. You don't want to have them huge, but like these guys here are like specific to UDP, I think. Like a UDP message pool kind of works under different rules than a generic, potentially generic like message pool for normal messages. Yeah. So okay, no, let's not make it generic. Let's make it specific to UDP. UDP packet pool. I guess I can leave this where it was before and change it like this. Yeah, whatever. So yeah, we could even say that instead of accepting a GPA, whenever you want to create one of these guys, you have to pass in a pool. And so we basically acquire one packet from a instance of a pool. That's not bad. So like here, the idea would be then that OpenStream to serialize doesn't want a buffer, it wants a pool. And so here we do um, oh, I put packet inside of it then, which kind of implies that then create, we want it, so then we do want create in the pool after all, I guess. So it contains data. Yeah. I guess an alternative could be that if you don't give it a pool, you give it a packet directly, then it doesn't need to try. This makes this function better, but then you have to do more stuff on the outside. That's a minor thing. I think is fine like this. Hmm. Okay. Then yeah, this is kind of silly what I'm doing here. Yeah, whatever. Okay, let's leave it as is for now. So serialize now has a UDP pool packet. Now let's use this stuff. Is it client network now that has to deal with this? Yeah. The network now, among the various things that it has, it also needs to have a pool. So loop handle, in the end, we don't even care. Actually, I guess we can do that right away. I have GPA right away, so we can do this. Can even put it somewhere else. Where do we care about the UDP pool? Where we're doing UDP stuff. Like here. Okay. Now there's a pool here that we can access in theory. Ooh, I guess that there is a difference though. Here we want this message pool to also. I guess there's a difference if the message pool is for messages that you're receiving or sending. Because if you're receiving a message, there's some completion stuff that you don't care. But if you're sending it the message, you also want to give it completion shit, which we could put in there no matter what. We just reutilize the same memory for both sending and receiving, and then when receiving, we just don't touch the other part. That also works. Okay, give me a sec. I'll take a quick break. I really need more tea, and then I'm gonna continue. Sorry, this is gonna be like this for a while more. This is just me moving around a bunch of evented networking stuff and trying to make sense of how the overall life cycle of everything needs to be. And that's annoying because you like whenever you need to close a connection, people that were here earlier have seen that whenever you need to close a connection, you have to wait for all the other async stuff to be done. And then different async things could be triggering the failure. Like the failure could be triggered by a read or a write, and so you need to do all the bookkeeping necessary to make this stuff work together nicely, which is, I don't know, boring. So I'll be right back. Okay, I'm back. Do. Okay, we have a message pool, and our goal was to use the message pool to send messages. Right. We also need a loop, but OpenStream wants a loop. I mean, but the other things wanted a loop too. So there's a loop in here. Oh yeah, there is a loop in there. Okay, we were saying that we wanted to give a completion to each message. Which kind of makes me think that this UDP pool then maybe should not be in here. Although I guess it could still stay. There's no problem with that, I guess. Let's do this. I guess we just want a generic send function at this point. Like we have send here that does a TCP queue write. Similarly, we want, I guess, UDP send or a send message. Maybe this should be under a UDP namespace. But if we put it in a UDP namespace, then we can't do dot anymore. Yeah. So that's not. Maybe a host connection should keep around a host address. So we don't need to parse it over and over again. Sunday dev time? Hell yeah. Cornex dev. I've never written any Zig. I think I might give it a spin. Well, if you're interested in trying lower level programming and you want to take on the challenge and like the responsibility and the privilege of being in control of aspects of your software that you normally don't have access to, uh, Zig is going to be a pretty interesting ride for you. I can promise that. I dove into Rust programming and that was fun. Okay, Zig is very different from Rust. Rust has a, I don't know, to me, seemingly endless amount of Rust specific concepts and Rust specific things that you need to learn to do with generics, traits, sigils, symbols, macros, colons, turbo fishes, that kind of stuff. Zig doesn't have any of that. It has comp time, which is a form of metaprogramming that is somewhat unique to Zig, although it's, how can I say, it has its own rules, but it's much more tied to, practical mechanics of making these things work. Although, well, to be fair, it's not like the Rust stuff is completely arbitrary. That one is also tied to some aspects of reality, but I would say Rust is much more abstracted in general. Like with Zig, most of what you do is more directly tied to solving your end problem than in Rust. And then whether you like it or not, it depends on you, I guess. Some people really enjoy uh, writing in a language that has a bunch of abstraction, but also they basically get value out of those abstractions. So that's fine. Zig kind of it's basically for people that prefer to get value out of. Okay, so we've given a message. The message has all in itself everything that it needs. I guess we could stuff in there a user pointer, or we could do field parent pointer shenanigans. buffer. So with this, now we can go in here and we can say that once the write completes, we can also do there we go. With this, we free the packet. When we release the packet, that's perfect. Technically, on the client, it doesn't even need to be ref counted because it could be returned to the pool right away. But that's fine, I guess. I guess an improvement could be to make this generic or something, and remove that for the client, and just keep it for the server. But whatever. I guess I can leave a note. Okay. Okay, so app uh, activates the audio stuff and then sends a network command like this, which makes much more sense. Okay. Now I need to figure out what happens when things go wrong. Well, actually, we need to make this work. This is not yet in working condition. That's the next problem. Missing streams. Oh, yeah. Okay, we'll get to that. Client media has a bunch of network code. Oh, God, we'll have to do something about. But it also has all the audio code. Yeah, these should all be resources that go inside a call. You know what? Even in not streams, but what's in fucking active call? There's status. I guess it's in here that we need to do the rest. Hmm. Honestly, I think that this stuff should probably exist always inside a voice call. It doesn't need to be separated. Yeah. Yeah. No, it's not CH. Oh my god, it's AC, active call. Stream error, I think, can be local. Oops. What's an auto array hash map? It's basically a hash map that it's an array list plus an hash map. Items get put into the array list, and then the hash map contains indices into the array hash map. Well, sorry, into the array list. So if you want to loop over your items, you can do so because efficiently because they are in a array list, and then you can look for them efficiently through the hash map index, and it remembers insertion order. So it's for when you need a little bit of both, I guess. Hmm. Why am I moving this stuff back in here? Am I doing something good or am I doing something bad? Am I doing something good or am I doing something bad? I'm moving back everything back into the main application. It is part of the life cycle of an active call, so having this stuff not be moved into 10,000 different things is not bad. You know what? I'll commit. Oops. Now, the problem of putting this stuff here is that the network now needs to access these fields. And it's not immediately obvious if somebody will try to yank this stuff away from it. I guess nobody should be able to yank this stuff from the network because we basically wait for the network to clean up. Although we do want to stop certain stuff right away. Wait, thread init and thread init are Windows only? Process init. Okay. Yeah, I'm not super in love with how this stuff is playing out, if I have to be honest. Really not really much in love. I think that those things should be global variables inside of media. That really seems the better choice. And then yeah, I'm not in love with this work. And then it does need to have separate functions, one for initialization, one for deinitialization. Um, but that's it. So kind of like this. Like we basically like we have all this business logic. Media receive. Yeah, okay. So let's move this here. Even right at the top, I guess. On DLL load unload. Oh my god. Yeah, I think we want to keep these guys here because at the end of the day, we want to be able to interact with the buffers. Not with everything, but we want to interact at least with the buffers from the network thread. Actually, in the end, we only care about the, well, no, we do care about both. But we want those to be, let me think about it for a moment. These buffers have to be synchronized between libxcv and the auto threads. There is no escape there. Okay. Then we have a bunch of business logic. Then we have run thread. Let's not do this. Let's do instead like init. Let's move, I guess, open activate and deactivate, I guess. Yeah, these guys are singletons. Oh, and the idea is that when we are leaving this thread, we were the ones destroying the call. Interesting. Now it's not that easy anymore. Oh, fuck. Now, yeah, now it's more complicated. Okay. And so here we were receiving, and this is the code that does multimedia stuff on receive. Right. Right. And then there was also media send. Okay, this needs to be different. So the networking stuff needs to go into network. And yeah, who does the multimedia processing work now as a thread? Who does the work? I guess it's the network thread that does the multimedia processing work. That's fine. At the end of the day, it's not really synchronized with anything really. We basically now need callbacks. Something like this. Like received message. I think networking is so much easier with Thespian than libxcv. Do you have a link to Thespian? Is it something that you wrote? Oh. Wait a second. Wait a second. Wait a second. Wait a second. You were trying to trick me, huh? You were trying to trick me into adding a C++ dependency to a project, huh? D2 is pure Zig? No, it's not. It's not. I was half joking. I mean, I'm not delighted to add C++ dependencies, but I've done it. SRT was C++. Let me think. Right now, it's Zig, and the only C dependency is, well, no, there's a few. So we depend on Opus, that's C, and then whatever it's going on behind DVUI, so SDL. I would say it's mostly Zig, with just a couple of C things. Well, if I have to be honest, this libxcv is a little bit verbose, but so far, every time I needed to implement something, I never encountered like a, you know, um I never encountered a blocker where it was like incredibly problematic to make certain things, to express certain things. So far, so good, honestly. Okay, so now how do we drive sending messages? Sending messages is basically the audio thread that writes samples, and once it has written enough samples, sends a async event to the event loop, basically. So libxcv right now is not perfect. For example, Johnny was saying that he was having trouble on Windows with TCP, and there's definitely a good list of to-dos in there. But I think that so far, when it comes to these libraries, is the one that you can expect to over time become more complete. And in any case, it is already pretty complete. Yes, there's still missing a bunch of to-dos, but so far I've used it for a bunch of things and it works. And what's funny is that I've used it for everything except what Mitchell uses it for mainly. So I've been doing networking and Windows, and he doesn't do Windows and he doesn't do networking. He only does like file access. So it has timers. It has like kind of like conditions. They call it async, basically, so that you can you can basically have the event loop participate into multi-threading coordination, multi-threaded coordination. So that's nice. That's what I'm going to use here for sending messages, basically. So personally, I don't hate it. Also, I think that the interface that it uses, it's the same as libuv. So you could even say, well, this is not complete enough. I'm going to use libuv. And then once you think that libxcv is good enough, you can kick out libuv. And in theory, it should be a close to one-to-one mapping at that point, I think. Okay, so what I was looking at is I wanted to keep moving stuff around, right? So I basically am disassembling this function. We have this udp.read, which to some degree should happen in the network thread. So the outer thing should happen in the network thread. The inner logic should be, I guess we can go from here to here. This is the logic. This is what we do when we have received the message. And then this outer shell is what we do in the network. I think it should be, I guess just like we have UDP send, we want UDP read, I guess. And we do this in there. Well, no, we want to issue the first read. And then we want the callback to be defined in here. Actually, this could be all done in line, I guess. Yeah, this doesn't need to be a different function. This could be put in here. Something like this, right? Receive message. Okay, now do we need to do any freeing? Because right now here we have only one read buffer. We use one read buffer at a time. That is actually fine. Yeah, we don't want to have a bunch of these things flying around. Just want one. Oh, fuck. What's the out format? I don't know, man. Out format. Is it playout.format? I think it's playout.format. Okay, let's see. We receive a message, parse a header. We look at the stream ID from playout buffers, not found, instantiate a new one. Grab an instance to it, write to it, and that's it. Okay. That makes sense to me. So I think that with this, I can delete this function entirely. And also media receive is useless now. Well, it was already. Now we need to worry about media send. Okay, we just need to move media send. Receiver we don't need. Yeah. So media send basically is... Oh, this is the guy that was woken up by... Right. This is the function that was woken up by our audio thread. So this now needs to become a libxcv async thing where the audio thread knows how to trigger the async thing. Now I need to remember how to do this stuff. Okay, let me think. Well, I guess basically this becomes a, like, what is it? Yeah, receive message. We have the callbacks. That function here, I guess it's mostly still the same. Let me see. Media send. We make this one also called by... Yeah, it's a callback basically that's called by the event loop. Okay, you know what? We need to start from the audio thread callback. So where is it? Audio callback capture. audio callback playout. Yeah, we need to fix. We need to change audio callback capture to do stuff. We're grabbing a pointer to the capture buffer because it's giving it back to us. But I mean, we don't even care about this shit. We have the global. We know what the capture buffer is. It's here. It's this bad boy. Like, we literally could do this. And it would work. Okay, so the audio thread calls this function. We write in our capture buffer some stuff, but guess what? This motherfucker has a mutex in it because this guy was designed with multi-threading in mind. So what happens is that somebody writes to it, but then there's a condition because it expects that there's another thread somewhere that is sleeping and waiting for it. And that's kind of basically what we want to change into. We want that condition and that mutex to be a libxcv async thing, I think. Wait, actually, do we still want a mutex? We still want a mutex though, because it's still going to be two separate threads. Basically, the only change is the condition. Either that, or we keep this in. Also, this is interesting because they're like it's very the capture buffer and the playout buffer are somewhat similar in some ways, but not in others. So they need to have two separate implementations. And the existence of that condition is one of the things that make them different, but makes them different. But in any case, so we could change that condition into a libxcv async something. And that way the send callback would be called by the network thread and we would be happy. And I mean, who is better than the network thread to do network IO? Plus a little bit of encoding, decoding, whatever. Okay, let's do this. I don't remember if it's just async or something else. I don't remember how this stuff works. I actually used it already, but I just do not remember how that works. Create a new async. An async can be assigned to exactly one loop. Okay. Then, yeah, one guy calls wait. And one guy calls notify. So on Mac, we use eventfd, which is a shitty solution. POSIX write. Let's see. Linux plus IO luring eventfd is used. If the eventfd write would block, then we assume success because the eventfd is full. Interesting. Does it work with IOCP? Yeah, of course. It's obviously Windows, of course, has to be more opaque. So who owns the async? I guess this guy owns the async. Right? Hmm. Init. Oh, yeah, it's the wait call that binds it to a loop. And that's it. Okay, so this guy has it. We also have a mutex, though. We really need also the mutex. Yeah, we kind of do. Okay, so we have changed the condition, and now I guess we need to worry about wherever this stuff is instantiated, which is inactivate, because now all these things are different. The capture buffer now needs to have the XCV stuff to be initted. Yeah, of course, all these things can fail. Why wouldn't they? Okay. So we would like to send to the server our microphone data. The problem is we kind of don't want to start sending microphone data until the server has confirmed that um, we succeeded with the initial handshake, in a sense. So we kind of need more state tracking, and we need this to be inside UDP send, I think. We basically want a UDP send where on success, we call UDP send again. Now we call wait. We start waiting, basically. We kind of want a special callback, honestly, for that case. I'm thinking that we should really not use that and instead do a separate call. Oh, you know what the problem is, though? Wait. It's not it's not these. When like this confirmation doesn't say anything to us. This confirmation is from the server. That's what we would like to do, but we can't. So I guess we could do it in the old-fashioned, in a more old-fashioned shitty way, where we basically we sleep. We start sleeping. We sleep. Yeah. Okay, so now it's not just UDP. Now it's more complicated. Now it's also I cannot do UDP.read. This is bad. I'm sorry, I'll have to do this. Otherwise, I'm gonna do stupid shit. No, I want to call wait. So I want to call wait on media dot capture buffer dot xcv async dot wait. Oof. So we're gonna need some kind of completion. We're gonna need some user data, and then we're gonna need the callback. Right. Host connection, I guess. Is there a reason SCD meta field info doesn't support optional? I'm not sure I'm following what you mean. Field info. You mean you would like to pass to field info an optional something and then have it ignore the optionalness and then just reply with what's inside the optional? That is, I would say that would be unsound behavior to some degree. Just unpack the optional on your end if something is optional. Like you I guess in some situations it would be more convenient if the thing did it for you, but you can always do it yourself. The reason why I was saying that I'm not sure it would be a good idea, it's because imagine that you have an optional that contains an optional, that contains an optional, that contains an optional. You kind of would like probably to have control over what's going on there instead of having a function that like kind of magically unwraps everything. It's a bit of a degenerate situation. Like it's weird, but yeah, but by having functions that are kind of trying to do that for you, things get wonky, in my opinion. I'm generating types. I don't know when it's optional. Well, yeah, you do know when it's optional. You just do a little bit of in introspection uh, before calling field info. Actually, you could basically implement field info yourself and just add the optional case and do what you want to do in the optional case. And do in the optional case what makes sense for your use case for you. Yeah. It's just that it's kind of foot gunny if you have functions in the standard library that start doing that for you automatically. I guess that's kind of the idea. Okay, so basically this should keep waiting on the capture buffer. The capture buffer occasionally notifies. This is still a condition. It's just an async one. It's a condition with extra steps. So it keeps waiting. The networking thread, the microphone thread occasionally notifies it. When we get notified, we send out a packet, and that's it. I would even say that we could do something better. Still as a temporary hack, but we could do something better. So we use sleeping before issuing this stuff. But probably the microphone buffer will be full already by then. I'm kind of thinking that maybe we should uh, like empty the buffer after the connection has been established or something. Like maybe here, but then we need to account for that stuff in here. Oh god damn it, I had this distinction of the food thing versus data. Okay. Okay. Oh, we also had these encoder, right? Uh well, guess what? This encoder is here now. Capture encoder, which cannot be done at comp time. Oh god, I hate C library. God damn it. I'm fetching a lot of URLs synchronously, and it is causing much issues. Is it possible to do it asynchronously in Zig HTTP.client? Sure. You just need to have multiple instances of client, multiple TCP connections, and then you need to manage. You need to orchestrate your multiple instances according to what you want to do, pretty much. Maybe you will want to have a like an architecture where you have like a stack of URLs that you collect as you open URLs, and I guess somehow figure out what is the next URL that you need to open. I'm assuming that you're discovering them on the fly and you don't have a prefixed list. But so you have basically you keep collecting these URLs one way or another, and then you have basically a pool of clients that that pops from that list, from that stack, and then I don't know, does whatever it needs to do. Is it possible to first create a connection and send multiple requests in that channel? If you want to request multiple resources to the same remote host, meaning you obviously are connected to one host and you want to request, 5 pages from that same host, because obviously if it's different hosts, then you will need different TCP connections. But if it's the same host, then yeah, HTTP supports pipelining. Even HTTP 1.1, I think, supports pipelining. So you're totally allowed to send multiple requests without first waiting for the response to come. So I don't know which client interface, I don't remember how the client interface looks like exactly. Um, but it should there should be a lower level interface that allows you to just send multiple requests and then collect replies afterwards. But I'm not sure. You know what? I remember that HTTP server is very bare bones, and so it's very simple, and so you can pretty much use it to do whatever you want. The client, if I remember correctly, was more complicated, and so certain usage patterns probably are not really fulfilled by it very well. Response storage. Yeah, this interface is definitely not the right one if you want to do pipelining. If you want to do pipelining, you basically need some kind of, I don't know. Like you need a read stream and a write stream to some kind. There's no other way otherwise. So I don't know. Might be that the current client implementation just doesn't support that. But I guess my point is, it is totally doable in theory, more than just in theory. It is totally doable in terms of what the HTTP protocol supports. Pipelining is allowed. Again, including in 1.1, I think. But also keep in mind that maybe some servers might not really appreciate that. There's also that to keep in mind. So you like beware that if you ask 10,000 different things all at once, the server might not like that. But yeah, it is possible. I don't know then if this client supports it or not. Are you passing the error as a reference just to not allocate, or is there a different reason? The error. Are you talking about this guy? Here? This seems to be the only error that, okay. So that's an interface that Johnny created. Basically, what I think is happening is that this is like a diagnostics thing, kind of pattern. So when you're trying to open an audio stream or like do complex audio operations, there are multiple reasons why it might fail. And so what Johnny is doing is basically using this as a diagnostics thing where we can get more info on why the heck this thing failed. So having a local instance is good enough because we just need it in case of failure locally. And then once these things are up and running, then that like they don't capture a pointer to this value. As far as I know, they are only used to report errors from this operation. You know what? Let's maybe see if we can go to definition and see if that's true. Yeah, as you can see, the only references are basically setting that error. It never gets captured. So it's fine to have the temporary variable here. We don't need to put it outside. And it gets also reused. But like if this thing does an error out, then we use it again down here, and we use it again here and here. Go style. Yeah. Go PTSD. Yeah, I mean, with Go, it's I mean, it does look like a little bit what they like the usage pattern in Go, but obviously there are some clear differences, right? Well, I guess if we here's the clear difference. In Go, this would be the only error thing, so you could even assign to it, forget to check it, override it a bunch of fucking times, and everything would be a problem. In this case, we write to it, but then the function returns a proper Zig error, so we are kind of forced to deal with the Zig error. Like this is a secondary error that gets used in combination with normal Zig error reporting, and I think that is much, much better. So in that sense, it's not like Go. You can't be sloppy with this. Okay. We have received the message. No, sorry, we want to send a message. So we get some memory. I guess we can do, we can defer, release it. Should it be up to us? No, we should not take ownership of it in any shape or form. So this should be the caller that does all of this stuff. So, okay, we get a message, header, write this stuff, see how much other stuff we write down. Use the capture encoder. We have a local buffer that we use. No. Wait a second. What's going on? Okay. We write to the message our header. Then we say the data is everything after the header, which is correct. We lock the capture buffer, correct. We defer unlock the capture buffer, yes. Yeah, here we have the condition wait stuff. Now, the idea is that if we got if we were called if we were called, then it means that there is enough data. So this should be more like an assert. No more condition. So we assert. Although this is not optimal, but it is fine for now. At least it captures, it catches when this error condition happens. What we probably want to do is maybe check for this a little bit earlier if we can or something, and then basically say, kind of report that no, there wasn't enough data, so abort. Okay, and then there's this buffer. Oh, we read from the capture buffer, from the ring buffer, we read in here. That makes sense. Yes. And then we encode this in data. Tells us how much we have written to it. We add that to the size of the header. That tells us, oh, yeah, whatever. This is not particularly interesting. Right, and this was doing the send, the shitty send, which now we can get rid of. And then we say instead return MSG. That was given to us. We don't return shit. We basically just apply side effects to it. So we return. Oh, no. We're using this wrong. Now I see. I see what we're doing. Okay. I see what we're doing. I see what we're doing. We are writing to some slice instead of appending because this is an arrays list type of thing. So we need to append to it. So we append the header. Oh, and you know what? Then we can actually call it MSG. Let's go. We append to it. Buffer, blah, 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 blah. Oh, but this motherfucker wants to write inside of a slice. Right. Hmm. I guess we just give a pointer to it. It writes, and then we set len. We increase len. Hello, you reading chat. Yes, I am reading chat. Okay, I guess that's how we can do it. So returns true. And with this, send is done. Let's see if the network knows how to use this correctly now. Now we need to only understand what to do with ownership. So I guess here's how we can do it. If not, then we do make message the init, not the init, what's it called? Release. And then we return. No. Okay. So that's kind of the idea. Uh, and then we wait again. Mhm. So this should all be getting us very close to a more sane way of organizing all this shit. That is for sure, man. Holy cow. Um, yeah. Do we even build? We probably do not build. Show me. Show me the errors in my ways. For I have definitely seen a lot. No field name voice in start media connection details. Okay, let me see. The server told us that we are good to go for connecting. But we don't know if we agree. Oh, no. Oh, I see. Yeah, okay, let's keep it. Let's keep the voice. Okay. Expected one argument. Oh, one state. Sexy. Error is ignored. Try. Okay, let's see what happens now. Oh, a few things. Non-extern variable with opaque type. Oh, yeah. That's a pointer. That is indeed a pointer. Missing start field voice. 540. No. Wait a second. Yeah, we receive media connection details from the server. But then when we make our own thing, am I really this dumb? No, I'm doing open stream. Right. Oh, that's the thing. Okay. Previously, I deleted basically voice from the wrong thing. Yeah, no, there is no voice ID in here. No field and function member bind in client app house connection struct dot sock. I think I want to change this message. You know what we can do to make this less horrible? There we go. Now this is a little bit less horrible. No read buffer? Really? Oh, read buff. Certain pointer optional array or vector type found. Something else. In as bytes called on network 445. I think there's something missing in here. But okay, it's basically where we're calling. We're actually already there, unfortunately. It's where we're calling field parent pointer thing. What is the font you use in your IDE? It's called it's JetBrains Mono. It's pretty nice, except the cursive, like italic. Italic in this font is disgusting. I can't even look at it. But if you don't use italic, then it's very nice. Okay, wait. So give me more trace. Nothing import instruct media connection details. Oh, we need to solve also those guys. Okay, server, let's go do that. We don't do port. Now we need to do the other things. We need to do the nonce. We need to do TCP client and nonce. Okay, now the metaprogramming stuff. Okay, let's see. So what is going on here? We're doing a 2 bytes as bytes that doesn't work right. But it says network 445. Okay, so it's inside send. Yeah, I guess it's here. So basically we're trying to do as bytes to header. Oh, fuck. Okay. It's like pointer to header. Yeah. Happy now? Happier now. Expected type U11 found U size. Interesting. So len is generic based on how big you make the bounded array. Okay. Cool. I'll take it. HC is not accessible from inner function. Network 446. All right. Expected type pointer to this found this. Protocol meter 30. Pointer class must have a known result type. What do you mean, dude? You have their known result type, you son of a bitch. You were bitching about it a moment ago, so you know what this thing is supposed to be. God damn it. Field parent pointer increases pointer alignment. What? Align cast? That error seems weird to me. Discards const qualifier. Oh, god damn it. Give it const. Give it const. It's fine. It's fine even if it's const. Other guy also increases pointer alignment. Yeah, well, yeah, it does. Oh, I think I get it. So let's do this. Let's do this. Except the type U8 got const U8. Beta slice is const? It's given to us as a const slice? Interesting. Yeah, we definitely want to const cast. But only here, I think. Are you done complaining? Field fire pointer discards const qualifier. But I'm const casting, dude. Why do you not like my const casting? Oh, wait. I know why. This guy. Here. There you go. Okay, now I think we're down to some formatting error somewhere. Invalid from a string S for type message. God, please tell me that this error is not pointing at the wrong location. Because for some reason, FMT errors sometimes point at the wrong location. Media, wait, was that what? Client media 508? No, this is not it. This is fine. This was fine. Son of a bitch. Ah. Are the line hints also Helix specific? Yeah. ZLS provides the diagnostics, and then Helix has inline visualization. You can get the same end result also in Vim and also VS Code if you want. VS Code has a thing called, I think it's called Code Lens. Maybe somebody in chat can confirm more than I. But if you install the Code Lens extension, you can get inline error messages also in VS Code. Yeah, and then you have an LSP provide those diagnostics, and it doesn't matter the language. Like once you have the visualization in place, then whatever source of diagnostics you have, it works out. Vim has also the same thing, but I don't know what the name of the extension that provides that is. There is an extension that allows you to have inline error messages. I just don't know what it is. Okay, somewhere we are referring to a UDP pool message. We are printing it, and that's fucking stuff up. So my hunch is that this is happening in client media, but it's not this guy. Read this many bytes, message.len. That's fine. Opus encoder error, that's fine. 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 Yeah. So this guy seems fine. Let's go to network. No logging here. No logging here. Yes, logging here. There we go. Open stream. Boom. And the message is OS to serialize. So this would be message.date. Dot slice. Found it 372. Not mentioned anywhere in here. Yeah. Yeah, this trace here is trash. Holy shit, it builds. Okay, the fact that it builds does not mean at all that it works. So if anybody is getting weird ideas, let me tell you, the fact that it builds doesn't mean that it runs. Not even remotely. Test. What? It works. Okay, never mind. Refactoring successful. Holy shit. That went well. Man, you know, yeah, let's go. Man, don't need Rust. If it builds, it works. Also in Zig. I did not expect that. Although, I mean, Zig was giving us definitely all the a bunch of type safety that we needed. The thing that Zig doesn't give us type safety for, unless you go in very roundabout ways to request it, is, you know, the types don't reflect correct management of the application lifecycle, like spawning threads, setting up, events in the event loop. That doesn't get reflected in the type system unless you really want to, right? I guess the point where Rust would prove useful is if you did all the work to get basically generic types to represent parts of the lifecycle of your application, so that you can guarantee that at a given point in time you can do certain things because you can get that through the type system. But I wouldn't want to program my shit in that way anyway. So yeah. So in the end, basically all the fiddly bits relative to setting up audio stuff and everything else ended up being fine, and so the refactoring was successful. Now, here's what we don't do. We still don't do cleanup correctly, like not even remotely. And also, I think on the server side, so let me open this. I'm going to connect and disconnect right away. Oh, this is still very spammy. Yeah, it tells me new client. So what we need to do now on the server is start parsing the message that we received from the client, like the like hello message, and use that to connect the UDP stream to the existing TCP connection, so that the server knows that these two things are the same client, and yeah, etc. Then do the rest. Congrats on it working. Thank you. So, okay, I honestly did not expect this to, to work first try. But as you can see, there is a lot basically of bookkeeping that needs to happen. And async without async, well, non-blocking IO without async await is very, it's a bunch of spaghetti, to be honest. It's not the end of the world, but it's definitely way more verbose than it would be with async await. That said, you know what would happen with async await? That we would basically be able to write blocking looking code, but then who does what would be extremely complicated to make a sense of. Like you await and then you continue, but then now you might have a switched thread. You don't know, or rather, I guess you can know if you are precise in keeping track of that, but it's not immediately obvious. Here, it is kind of obvious who does what, like at the end of the day. For example, it is very clear that release is a callback that gets called from the network. Come on, dude. Go to definition. G? Oh. Why is this all caps? So like go to definition. Because if you imagine this could be, instead of a callback, this could be, well, callback, instead of function that gets called as the result of returning from the event loop, this could be just either a function or even some lines in the body of a bigger function. And then only those lines get called from a given thread. Because then you afterwards await something else or whatever. Or you have like a while loop or something. So trade-offs. Async programming is intrinsically complicated, I guess. And no matter how you dress it, some of that complexity has to exist. Yeah. Okay, here's what I'm going to do. I'm going to do the last server stuff. And then I think I'm going to call it a day. And I'm going to stop the stream. And then maybe tonight, later on, I will join Discord Legacy. And, you know, there will be a moment in time where people will come together for dinner. And while discussing things and sharing trivia, they will say, did you know that people in 2024, they used to call it Discord? They didn't know yet. They just called it Discord. They didn't know that. Anyway, those who understand the joke understood the joke. Everybody else, it's fine. Let's go into the server. So we give to the client. We tell them the voice channel that the voice channel ID that they want to connect to. Technically, we're doing it wrong here, because here we should remember that they are, according to us, they should be connected to that voice channel. So there's some some bookkeeping that we need to do ourselves. But then we give them a super secret nonce, you know, generated randomly. I generated this randomly once and hardcoded it there. And then we tell them what their TCP client ID is. And then they connect. So this happens in server media. In server media, then somewhere we receive read rooms. Here we receive that packet. And I guess we need to do something better. So we parse the header. But now we need to parse the rest. Yeah. I think my metaprogramming around messages also needs some adjusting, but okay. So new client. Here we need to say, yeah, we put this stuff in our room, but also we need to say, yeah, this client should be connected to this other TCP connection. I'm I'm thinking that we're also suffering in the server a little bit by trying to keep multimedia and non-multimedia stuff separate. And then that kind of tricks me into duplicating stuff that should not be duplicated. Instead, it should be integrated together. Hmm. 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 Yeah, I'm basically like creating a separate state for the media server, which I'm not sure it's a good idea. IP client map that is good because it's useful for mapping UDP stuff. Default room, whatever. Completion, these things are fine. Hmm. Yeah, basically, what I'm thinking is that this state, even though the media server is like a separate file, it still needs to have its main state connected to like put where the rest of the server state is. For client, it made sense to keep some media specific state in the media file because that was like a singleton stuff. But these things are this thing is like saving pointers to clients and stuff, and it has this client is a different client than my other client. Like, what the fuck? That should not be the case. So I think I really need to merge this stuff server wide. But you know what? I'm not gonna do this now. I think I'm gonna call it a day. Yeah. So yeah, I'm gonna call it a day. Thank you all for hanging out. Let me see if there's anybody streaming. There is somebody on YouTube. Maybe. Let's see. Is Marigold still live? No. The stream ended already. So never mind, I guess. Is Toggle live? I'll send you to Toggle if he's alive. No Toggle, I think. So yeah, I'm gonna call it today. Sorry. Marek counts.